ready.
Are you ready? I'm just asking.
Not born ready, but
yeah. So. Hi everyone, welcome to another episode of Munro Live. Jordan Arocha here. I'm with Kevin Hardy. Kevin is going to be the smart one in today's video because, full disclosure, I've got very, very little prep on doing this moto.
Corey was supposed to be here with us.
Oh, yeah. Well, I wasn't going to say the name, but now that it's out there, Corey was supposed to do this and had a hard conflict. So I'm dropping in, maybe just to help with an intro, and then I'm going to hand off to Kevin for the most part. Hopefully I can supplement a few things along the way. But today, the topic, we're going to be going over the front electric drive module on the Hummer. So we're going to cover rotor, stator, gear drive unit. What you'll see is a lot of large mechanical components and smaller electric components as we go through here. So Kevin's got a few talking points. As I said, I don't have as many as I typically would, but we'll give it a shot. So Kevin, why don't you get us started, and maybe we can start in the gear drive area and move on.
So probably one of the first things you'll see here is just, one thing that sticks out to us is it's very large, not necessarily surprising given the vehicle is almost a little over 9,000 pounds, but there's essentially three discrete assemblies within the EDM itself. So here we're looking at the main motor housing where the stator and rotor, thank you very much, reside. The oil pumps here, a few other things. Yeah, thanks, I appreciate it. And then the inverter sits on top. And then you have essentially a gearbox bulkhead that not only packages essentially the entire gear train, which is sitting here on the table, but it also serves as essentially like a cooling manifold for the main motor housing itself.
And by bulkhead, Kevin, so you're saying this is actually sandwiched in between these two cast pieces, and this is largely carrying the gear drive unit component structurally, right? Like they're
yes.
Okay.
And in general, the bottom line up front with this is it's a very conventional execution. I think favoring speed, manufacturability, as far as accuracy, maybe at the price of some efficiency as far as components.
Yep.
And like performance as far as being like robust.
Some supersized torque management.
Yeah, I mean, there's tons of high horsepower and torque EVs on the road, not many that running 35-inch tires that weigh 9,000 pounds. So I think there's some aspects of that we're seeing architecturally present with this being it. I mean, I haven't seen a ton of drive modules, but have you seen anything like this?
No, not in this type of an application, right? The general orientation in having an offset like motor, like so rotor and stator and gear drive unit, relatively conventional. But to pass through a structural medium like what we're seeing right here with this bulkhead, I mean, this is every bit of 25 millimeters, if I calibrated my eyes correctly this morning. And it is quite structural, and it's sandwiched between two equally structural and large aluminum castings on either side of it. So I agree with all your comments in terms of being robust. Obviously, it is tuned to being able to, a lot of folks think about, well, the Lucid produces equally as much torque, right? And for sure, in terms of output torque, but there's another type of torque or reaction input as you're driving, right? So a lot of tests and driving conditions will simulate the wheels and tires spinning, losing ground contact, and then making ground contact again where the wheel speed exceeds the ground speed or vice versa. And what that does is it shocks the driveline unit. And when you're dealing with a vehicle of this mass, the entire system needs to be able not just manage the torque that it's capable of producing, but also be able to manage those shock load inputs in the driveline coming back into the system, which you can see by the large teeth, not just in terms of the tooth thickness, but also in terms of the spread, meaning like across the gear section, how much gear surface area is engaged at any one point in time. That's an indicator. The other thing is looking at the diameter, right? The size of this hub interfacing with that. The larger that hub is, meaning the span between, like in terms of diameter, the span between the hub face on this side versus the opposing side, that's going to be better for torque management. So a lot of little indicators as we look at this gear drive unit.
Yeah, and this is, again, this is the front drive unit. So this is pretty substantial in size, but obviously this is a rear bias vehicle, much like the Lightning. And that was the biggest difference we saw with the Lightning between the front EDM and the rear EDM was common rotor stator, gear chain optimized, if you will, for load seeing with respect to just how often it's going to be an all-wheel drive or four-wheel drive and towing and just different operating conditions itself. Sure. But go ahead.
What did you think about the differential, Kevin? I mean, anything interesting there?
There's nothing, like overly bespoke with respect to it, but it is kind of easy to show you with this configuration what unlocking differential does. And anything that has front lockers is cool in my book. So you can see here essentially this interfacing plate. Typically, as you see here, these could spin freely if this was within the case, but a little bit difficult to show you. And then let's see, of course it was perfectly balanced, as all things should be. And then you essentially have the actuator here, which you can see plunges, which engages. So this is the electronic locking differential actuator, which would then apply pressure. This sits here sleeved, and it's a pretty tight fit, but then will essentially actuate this, and then now you have a locked front differential.
So for those of you who are unaware, like locking differentials are not anything new relative to electrification. In fact, they've been around for 100 plus years. Maybe not in this exact fashion, being electronically locking, but differentials that lock in general have been. Essentially, an axle, right? So either the front two wheels or the rear two wheels, if you lock them, they will not be able to rotate independently of one another. They will have to rotate at the same speed or overall wheel speed as one another. Whereas if you do not have the locker engaged, which is what Kevin's articulating here, they can spin independent of one another, even opposite directions. So what this is primarily for is off-road applications, right? So where you want maximum traction, you don't want to lose traction. And if you've ever seen someone here in Michigan stuck in the wintertime that's got an open differential, you'll see one side of the vehicle sitting there spinning and spitting up snow, but not really going anywhere. Right. This is going to help lock that up.
This episode of Munro Live is brought to you by Exter. Exter makes wallets, bags, and accessories that save you time, so that you can get back to living. Here at Munro, we travel often. So having Exter's Parliament wallet is great for quick and easy access while on the go. Made from environmentally certified leather, this wallet holds up to 12 cards, all easily accessible with the click of a button. For a slimmer profile, try out Exter's aluminum card holder, which features an expandable metal backplate, allowing you to carry more without adding bulk. You can travel worry-free with the addition of RFID protection to prevent wireless theft. Add on one of Exter's tracker cards to any wallet to make your wallet unlosable. With Father's Day coming up, now is the perfect time to add on an extra cash clip for Dad. This streamlined design allows maximum storage and is made to last. Save up to 40% off Exter's best sellers with their Father's Day bundle using code Munro.
So, but yeah, and then roughly, and I kind of put this in place, but so this here is the lay shaft that's coming off of the rotor itself has a gear drive, and you can see it over there. But it's coming through here, and it is, if I remember correctly, it's sitting and interfacing similar to this in vehicle position or in gearbox position. So on the opposing side here, we have the pinion here for the actual ring gear itself, which is off to my right, and then essentially this is driving off of the rotor. And I want to say this is 68 teeth going to 21 and then back to 21 off of the rotor. So it's roughly, I think it's like 13, I think the final gear ratio is like 13.3 or 0.26. So you're getting like essentially 3.2 here, and then when you're coming across from the lay shaft down to the differential, roughly equates to about 4 there as far as that. So
that might be a good point, as you were talking about that Park Paul engagement ring, to talk about some of the Park Paul engagement mechanisms. And, we brought a couple out here. We've got the Lightning here on the left-hand side, and then on the right-hand side, we've got the Hummer. And maybe, Kevin, if you could talk about some of the differences that you saw.
Yeah, so like the biggest thing here is, obviously with passenger-sized vehicles, we're not necessarily a fan of parking pause. There's a lot of cost and weight here. But with respect to trucks, in particular, towing and just the overall capacity to have a significantly higher, gross vehicle weight, a lot of these applications err on the side of being pretty conservative as far as falling in line with FMVSS specifications and not necessarily being risky and trying to omit some of these features. But to my right here, you can see the Hummers. What is interesting is the one here on the left is from the Lightning. So this is all plunging cross car to actuate, I don't have it out here, the Park Paul itself, but it has a beveled cut. Let's just take this from the Hummer here. But it has on that one a beveled cup what this would be actuated against, and then it would engage on the parking pawl within the Lightning itself. But it just was interesting here. This is all internal, essentially not serviceable to the owner of the vehicle or at the dealer level unless you're pulling apart the EDM itself. This, on the Hummer itself, this is the actuator for it, is external to the vehicle, serviceable, 3 fasteners and a single seal to the actual case itself. But now we're going into the actuator axle. There's some roll pins here that are missing. It has a separate harness. There's a spring steel, roller follower that follows this cam assembly. And then you can kind of see how this rotates and plunges up. And then this cup here on the top. And then there's even a closeout just to access this. And then all of these essentially are acting against the park pawl, which is sitting in a different orientation. So one of the things that's interesting is essentially this actuation here is happening vertical or Z in vehicle, kind of like so. And it's being actuated, let's see, where's it coming in from? In X, I believe. Don't quote me on that. But there's just a lot of complication here in comparison to what we see on the Lightning. But that said, we got an EDM here, we don't have the entire vehicle, and packaging conflicts drive a lot of costs sometimes. So
and at the end of the day, Kevin, and what we've seen as we're tearing these down, right, as all these electrified products come out of in the marketplace, we're seeing a lot of these park balls now start to go away on other applications, yes. Right? Tesla's now omitted them. I think Polestar got rid of them. We're seeing a lot of OEMs that we're in communications with, right? They're pursuing omitting these because, to your point, when you look at this assembly, it is complex. There's multiple machine components. There's multiple, any number of threaded fasteners to engage all of these. There's machined fits and surfaces, so a lot of costs.
Right.
There's integrated circuits, PCBAs. There's powdered metal components. There's a lot of stuff going on there, and there are things that we would generally consider our I'll say, lean design, right? Yeah. So we don't encourage springs or threaded fasteners because they typically yield, of any type of component, higher quality
and failure rates.
And failure rates and concerns. So, but if you're unfamiliar with what a park pawl is, it's not like Peter and Paul from the Bible. It's it's like PAWL, right? And so the intent of this thing is if you're driving in your vehicle and you put it in park, that lock, sometimes especially if you're on an incline, you'll feel the vehicle kind of like rock back and sort of mechanically click in place. What it's doing is it's engaging all the components that Kevin was just kind of going through. So specifically, you're waiting for one of those fingers to engage in one of these notches. And so via the driveline or the gear drive unit of the vehicle, the park pawl is intended to keep the vehicle from rolling. Nowadays, with electronic parking brake, right, so it's actually actuating the caliper, the brake caliper of the vehicle. Those are what's being used to omit these, right? So you get just the EPB, the motor on caliper unit, and you can omit the park pawl. But, and this is speculative at this point, but with a vehicle that's the form factor of the Hummer, 9,000 pounds plus curb weight, significantly higher GVWR, the gross vehicle weight rating, what it can hold in its entirety, it may be that they have, a front park pawl, or that they have a park pawl period because of the additional vehicle mass, but it's unique that they put it on the front axle. Yep. And so to me, when I look at that and I ask myself why, I'm thinking maybe they put this on the front axle such that it can be truly supplementary to the electronic parking brake on the rear, which is going to be in the brake caliper. So by doing that, now both the park pawl and the brake system can work in harmony or supplementally to one another. Whereas if you put them on the same axle, ultimately one of them is going to do the job more so than the other, right? Because they're on the same axle. So more than likely the brakes are going to take over for the parking pawl. And there's something to be said for having redundant systems from a safety perspective. There's a lot of literature from NHTSA about that. But I don't know. It's interesting. It's an interesting choice to put it on the front axle, but then you look at the weight and you're like, maybe that's why.
Yeah, no, absolutely. Because they might have ended up having to put a second system, which is expensive. And EPB is on most vehicles, and you're already paying for it. It's a pretty nice feature at this point. And I'm not even sure if you can buy brake calipers without them. But since we're talking about and kind of finishing up with the park pawl assembly, but this you can kind of see here, this is where the shaft would be coming in to the vehicle. Thanks, Jordan. And you get to see just the axis changes. So we want this to plunge forward. This essentially comes and grabs the park pawl assembly, which is riding on this bearing here. so it's going to be difficult. And then this would grab. And then here's all the rest of the actuation, again, in a different axis here that plunges up. And of course, there's a cap for this because they got to machine and get to this point. So there's just a lot of complexity here from both the parts themselves, the machining accesses to get to these parts and install them. So
well, and you also think about from a machining or DFA, DFM perspective, every time you have, here I'll just flip it up so you can see, every time you have one of these axis changes, it's going to a different machine and getting set up differently, right? And yes, there's 5 and 6 axis CNCs, and they'll flip this thing all around. But at the end of the day, for sure, tool heads that need to be swapped out. But for sure, from a machining perspective, you're adding complexity versus if you can do everything either in the same plane or same axes, your machining is going to be minimized to some extent. But then from an assembly perspective, a lot of this is going to be manual assembly because of the complexity, the machine surfaces. You can't afford, in most cases, to have a machine pushing other metallic items through a machined board because you run the risk of damaging those because it's not as tactile and you've got to be a little bit more
And frankly,
delicate.
there's just, when you look at the heads, a lot of things like this are just simply not, fortunately for us, until we get like fully, humanoid robots. A human is well suited to do a lot of this and not necessarily the case for any automation at this point.
Sure.
And then you can see here one of the oil pickups that's coming from the gearbox bulkhead, and then it's divvying out oil for this part of the system as well.
Sure.
But that's pretty much really anything of note to talk about here on this side. So essentially, this is encapsulating the drivetrain itself, or the gear train. So if you kind of picture this, here's the differential assembly coming through here, and then it'll be encased with this gearbox cover itself, and then the lay shaft gear here. So the rotor is directly concentrically in line with here. So we have like a single directed oil squirter right down the rotor shaft itself to lubricate it, dedicated to this. And then this is lubricating the top of the stator assembly, which is fixed inside of the housing here. And one thing that's also interesting, and you can see all the channels better on the other side, I'll flip it around, but each one of these is cooling the phase leads. So they're directed upwards, shooting right at the phase leads themselves, coming down from the inverter into the EDM itself.
Which is going to further benefit you in terms of efficiency, right? So obviously 800 volt capable system, right? You're going to end up like what we see in the Stator here. You're going to end up with smaller cross-sectioned copper elements or elements that are current carrying. That would include those phase leads. And then more so when you cool them, right? If you can keep these things cool, you can carry more current. You're going to be more efficient as you start to approach your outer limits of the ideal temperature range, right? These guys will get less efficient and super high temperatures. And so keeping those cool is certainly advantageous from an efficiency perspective. So not only are we seeing that, obviously with the Stator that we see here and the cross sections and the electrical elements, right, the bus bars, these phase leads, what we see in the Stator, so they're benefiting from going to 800 volt there, but they're adding to that, they're supplementing that by cooling the phase leads themselves.
But yeah, so essentially you would have this is the middle, what I've been referring to as the bulkhead, and you can see all these paths here for feeding oil. So it's being fed from this side, which is where the oil pump is, and pulling the system. It almost makes me want to feel like, if you remember the evil cat monocle from the Lightning, where there was a manifold set up here. One access, right, all exposed. Actually, most of it I think was as cast, and then they essentially had a plate that bolted on. Granted, we don't like fasteners, but I think in some ways, maybe in another iteration, you could end up with something more of a manifold setup, more similar to like an automatic transmission valve body, and try and get some of the oiling path complexities out. But and then this would essentially load into as an entire assembly with the gear train onto the motor stator assembly itself. And this is essentially, from what I've seen on some public literature, part of a family of vehicles, EDMs, from GM. Mm-hmm. But one of the things that's interesting, and hopefully they kind of are looking at this, obviously we talked about scrap rates and just off-fall, but this is a stamped aluminum over-molded seal. So there's one on this side, and then there's one on the other side of this as well. Very similar, but I'm hoping that for some of the smaller ones, and then there's one also here from the inverter, that maybe we can do some nesting and get some efficiency out of this. But you're seeing that, in contrast to an RTV seal, there's money to be spent here because it's an expensive light material that's being then loaded into a tool, shot over and overmolded. It's nice from the perspective of maybe on the cycle time perspective for building these, because you can essentially just nest, drop on, this gets loaded, versus the time it takes then to apply the RTV. So sure. That might be one aspect of why you're essentially paying the money to do something like this. And then potentially, depending on like mileage threshold, maybe it's also like a serviceability enabler for them as well. But
definitely.
It's one thing that's interesting. It's costly and it's unique, but there might be a good way to, I don't want to say explain it, but at least justify their decisions with respect to that. So.
Yeah, it's hard to say what the internal requirements are at GM, but totally agreed. You know, this is going to be a higher cost item, no doubt. You know, going further on the cooling side of things, obviously we've got this plate cooler. Nothing novel or new here, in my opinion, looking at it. Relatively conventional plate cooler where you've got ethylene glycol or coolant, like the water-based system, coming into the plate cooler. On the other side, and through a segregated set of passages, you've got oil coming from the gear train and the motor unit coming in the backside. So they're using the coolant to likely both heat and cool this depending on the operating condition, but I would say more so from a cooling perspective.
No, I would agree. I mean, this is essentially the front of the EDM, if this is front of vehicle, and it mounts here. And again, it's kind of to my point with respect to maybe a manifold assembly, maybe down in the future. You can see just all the multi-access machine operations and different cooling paths, because the oil pump sits here and essentially is pulling in from the bottom of the case and then driving everything up through this side of the housing, and then again the gearbox bulkhead itself.
I will say the one thing that was just mildly bummed to see in this is, you know, because at first glance when I looked at the overall EDM, I was like, oh, very cool. If you looked at the top of it, right, this void right here, the inverter sits right in this pocket, this cast-in pocket. And I'm like, oh, wow. And it looked fairly integrated relative to a lot of inverters that we've seen, which in some cases will have big stamp brackets that help support it, stand it off this, so they're like truly separate and segregated units. I was like, okay, not bad. It's fairly integrated to this overall housing. But it's cooled via ethylene glycol, and then we've got this separate plate cooler that's used for the gear oil. And so, you know, I thought it would be very cool if they were able to integrate the plate cooler closer to or part of the inverter, such that the ethylene glycol loops did not require separate hose runs to go to and from the inverter, to and from the plate cooler. And it's like they're so close yet so far, meaning proximity-wise relative to one another. I mean, they're within, you know, I don't know, less than a foot away from each other vehicle-wise, but we're not yet integrating the coolant loops. So I think in another iteration, I would like to see some level of integration there. I think it would be
and cool. Again, what we're seeing here for these ports, there's multiple ports. I'm not exactly sure what all of them are for. These are all filled with plugs, but essentially this is being driven across the top of the stator, and I'll flip this around so you can see. So we have these very discrete cooling ports that we showed here that are supplying the stator with oil. So these are shooting directly into here. These go against the phase leads to the top here, which are cooling. And these are interesting. They're very light, but extremely complex. There's 12 seals in general, which is, I find very interesting. They're doubling up every seal through each pass-through. Thank you, Jordan. But you can see here, 2 here, 2 here. But in another system, thank you. But in another system, which we saw in the park, Paul, just a single seal going into this. So, and there's obviously some other executions that are a little bit simpler. Here's one on the Lightning. We have it all integrated, 3 fasteners as well. Not directly analogous, but very, very similar. And then here's one off one of the Teslas as well. The biggest difference being here that these have EM shielding provisions, which both the Lightning, at least with this component, doesn't have, and the Hummer doesn't have, from what we can tell, at all, which is kind of interesting. So they might be mitigating any of those concerns somewhere else with another system, or just with MVH within the vehicle.
Sure.
But you can kind of see, I'm not sure, I can maybe get a little closer to you, Grace, but through here, this is where the resolver sits, and then there's cooling ports, so they're dropping and cooling the top of the stator here, and then the top of it here as well, there's another port as well. And then sitting here is where the oil pump would be, and the oil pickup, which we'll talk about here shortly, resides within this cavity here. Actually, while we're here kind of looking at it, we might as well just kind of talk about it. here you can kind of see, now some of these scratches from these machine provisions for the stator are from us just getting it out because it is a tight fit despite the fact that this is not a pressed-in stator, it's a bolt-in. But you're gonna bring it around? Just do the reveal here. So it's interesting, there's a lot of conversations about pressed-in stators, Jordan, versus the bolt-in stators. A lot of the people that we talk to that are going with bolt-in stators themselves. Yeah, you wanna bring it over?
Yeah. So what Kevin's referring to, obviously, stator is this, and some of them are bolt-in, where you've got bolts coming through the end of the laminate stack, securing the stator in the respective housing. In other cases, people will press in the stator, so it's an actual interference fit between the outer bounds or the outside periphery of the stator itself and the cast aluminum housing, right? You saw, as Kevin was pointing out, we've got those machine sections on the inside of this. So in some respect, this is a pressed-in stator. One of the downsides or concerns of pressing in a stator is as you're pressing it in, imagine you were working with clay versus aluminum because it's a little easier to picture. And if I were to try and press something cylindrical down the wall of a tube and I were clay, that thing may start scraping off that clay. Well, the same is true when you have steel and aluminum or metallic surfaces. So when we looked in the large particulate filter, you can see rather large, I'm going to be careful because I don't have gloves on, but rather large shavings on a brand new vehicle that very well could be from that installation process. We put a magnet to it. They were not ferrous, right? So it is aluminum in there because originally, in some cases you'll get gear lash. As the gears get to know each other, they get married with one another, right? So as those gears and those cogs interface, sometimes you'll get some metallic shavings that will come off of it. But given the size of these and also the fact that they're aluminum, it's very likely that those are due to installation processes like the stator that Kevin was just talking about.
And so, as I was kind of mentioning, when we talk with various customers, there's discussions because not only do you have the bolts, so here are the kind of the brackets for this that secure this into the vehicle itself. So these are all operations that are separate. These are separate components that you have to manage. And there's aspects to this that add weight and complexity versus just using the inherent benefits of your housing and whether you're heating the housing itself with a kind of a cooled stator and then pressing that into place. A constant concern that we have, especially for customers that are like just getting into the EV space, is just what we're talking about here. Mm-hmm. Now, some of these smaller ones may not be from that. When you're doing all these machining operations, even some of the casting suppliers that we've talked to have said that they struggle within at least a timely process to quickly clean these castings out after they're machined.
Right.
Because again, volume and cycle time and things like these things all matter. And this is probably, this shows why essentially that we're paying the money still to do this. This is integrated within a pickup tray, which is nice within this vehicle. The Lightning was a screw-on one, but technically not considered serviceable if I remember correctly. So, and then while we're kind of talking about the stator housing, itself, one of the things that is interesting here is this set of supplementary bolts. So typically this is just enough to secure it. But again, we've been talking about essentially a very heavy vehicle with high torque potential. And there's a set of secondary bolts here that marry inside the housing itself. Of course, these are dog head tipped and I can't get them in place. So we're kind of thinking that from a torque perspective, this helps stabilize the stator assembly within the case itself, despite the fact that there's a relatively large structural bulkhead here. So this is something that's interesting, and it may simply be just certain requirements that are in place that drive this cost and complexity within assembly. So
yeah, it's something that we actually see on like cradles and subframes of the vehicle, right? Where you take essentially a shear plate, like in effect, which is what you get here, and it lays over the top of these ears of the stator and it bridges to the casting. And what that's doing is it's adding locally at this joint additional potential clamp load. It's distributing whatever those rotational load inputs would be that would ordinarily, without that piece, just go directly into these ears, and it's dispersing those along the top of that stamp plate on the top and through the casting in a more significant manner. So just like we were talking about with the gear drive units, that sort of cross-section, the larger tooth engagement, the bigger hubs, all of those things, once again, a pretty concerted effort for that torque management, to no surprise, looking into this.
Right. I guess we can talk a little bit about cooling, since there's definitely a trend here with respect to some of the things that General Motors may be concerned about. So here's kind of a decontented rotor assembly itself. And one of the things that's interesting here is you can kind of see here the coolant is shot in through this side here. The rotor is spinning.
Yep. Is it oil or?
Sorry.
Yeah, the oil. Yep.
Oil's shot into this to cool the rotor assembly here, and then it wicks out from these passages here. Now the stator laminates themselves is roughly, there's 2 cores here, so they have like an alpha core and a bravo core, and they are common as far as stampings, but just askew, essentially inverted. And what they do here, and you can kind of see it, is there is a channel here. So oil is forced through here, and then it wants to go and wick outwards along the rotor shaft itself to the rotor end plate, and then there's a cooling pathway, or jacket, if you will, that comes up, and then this directs, can I have this please? Thank you. And then you can kind of see here, that might be difficult on the camera, but we will have some pretty slick CAD, it's already drawn up, that we'll throw on the screen for you guys so you can see a little bit easier. But from the video perspective, all of these spacers, typically they're cut out, they're not really needed as far as the rotor assembly or any magnetic fields, but oftentimes people will run oil through these to cool the rotor, or the stator, can't even talk today. But this is running across the shaft itself, up through here, and then back across the entire stator assembly, and then it exits out this pathway here. So, yeah, I mean, it's kind of interesting. One of the things that's, right now we're also not only doing the Hummer, we're doing the Lucid at the same time, and it's like a complete opposite. There's essentially no oil being routed through on the Lucid. So that's something that we'll talk about a little bit later. But it's just interesting to see. Let's see here if I align these correctly. So this is common, and you can see here essentially where it is blocked, and just you simply flip it over, I believe here, oops, to get them to line up. So common part, and just clock differently to allow for the cooling paths with the rotor itself. So that's something that we thought was pretty interesting with respect to this. So a lot of emphasis on, I think quick assembly, accurate assembly, cooling the overall assembly itself. So
for sure.
Which, unfortunately ends up in cost and weight in the system, but that's kind of one of the common things in general is weight begets weight, and cost comes with that. So there's a lot to be said, for lean design, lean design for manufacturing early, and unfortunately, depending on how fast they wanted to get into the EV game, you may not have the time. So I'm super sympathetic for the team if that was the case. Get it done in 12 months and let's go. So
no doubt. Well, it seems like we've covered most of the stuff here on the table.
Yeah, that's kind of it for me.
Yeah, no, it was exciting. It was exciting to walk through. We've been waiting to see this one for a little while.
Yeah.
Not too many surprises, but overall, kind of a cool setup given the size of the vehicle and how they executed that. Thank you, Kevin, for walking us through the details. I appreciate it. And if you would, on Corey's behalf, go ahead and hit that subscribe button, and we'll see you on the next round.
So, thank you. Appreciate it.
Thank you.